Hey, Energy Saver. Today, I want to show you what I was working on the last weeks. I was building the new Energy Saver portal. It will be so easy for you to manage your different energy saving projects, different sites, different clients, and upload your energy data in different formats to then get quick insights, run regression analysis, do weather normalization, and find out your true energy savings. Let me quickly show you how fast you can get insights from a data set. We will set up a new project, call it Energy Data Demo Project. Then you can set up organization names or client names. And this is obviously energydata.io. Find a location. I have a data set from New York. You see it's a autocomplete function. You can put in zip codes, you can put in street names, and then set your location. Here you can give it a little bit more prettier name, not New York County, New York, but this is just for display purposes. And on the previous step, the coordinates, they are responsible for fetching the right weather data for weather normalization. This was a residential building, and you can give it tags. You see here all the tags that I already used, just to group your projects, to find them easier with the search function. Let's just say it's here, this client 1, 2, 3. And this one I will skip for now and create the project. Let's refresh and search for the energy data pilot. No, this one was not the one. Energy data.io. How many do I have here? This one here with the client ID 1, 2, 3. Open this project. You will see a summary, nothing going on here yet, no sources connected, no readings. So we set up a new source. This one was, I don't know, gas or oil, but I guess gas definitely it was heating related. Call it gas meter 1, 2, 3. Gas is in, maybe it was cubic feet, but I'm more used to cubic meters. Again, you can give your sources different tags, like, I don't know, it's a smart meter, or I don't know what. Be creative. This one I will skip for now. We can configure it later. The same with for the weather normalization. Just create the source. And you have a energy source page. Again, not so much going on because you need to upload data. I used the file upload. I have daily data from 2 years in CSV file. You can upload PDFs, XLS, CSV files, and the algorithm is pretty smart and even really tricky formats, it is extracting the energy data right. And you can add not only your energy consumption, you can add something, I don't know, production output or other parameters that you want to investigate and maybe normalize for. This one was successful, 730 readings and total 47K cubic meters consumption. Here you see the nice, let's see, all-time data. Starting in January, heating related, then it's in the summer month, it's going to 0. And then in autumn, the energy consumption is rising again. What you can do now, aggregate to different levels. You can set up weather normalization. I know it's in the US, but still I stick to the metric system. We have Celsius and we have heating related influence. HDD for heating degree days. And then you can set up the base temperature. Let's pick 15 degrees Celsius. And then you can load the degree days. Still loading. Here we go. Then you can see here in the table view, it's already added. For the chart view, you can select them here, give it a different color, or say I want it as a line chart too. I want it on different axes. You can play with it. And as I said, you can add more variables here too. Okay, we see definitely a heating related correlation. But let's find out if 15 degrees Celsius was the right base temperature and run a regression analysis. Let's just take the first year, 12 months is good. It's always good for regression analysis to capture all seasons. So 1 calendar year is perfect. We can stick to the daily aggregation. With this, if the results are not clear, just play a little with it, aggregate it to weekly data or to monthly data. But I want to play a little bit with the base temperatures. Let's see, 14, 15, 17, and maybe 19 degree. Start the analysis. So now the algorithm is checking for correlation with all these different degree day values, where they are really correlated. Let's see, this is the result table. We can see here a really nice correlation. We have a small base load. This is not related with heating. And then with every degree day, we are using more gas. Let's check the values. Here we have the table. IR square value is always good. You can see here, it's slightly getting higher here. I don't know. Let's go with 17. You can go more in detail and check what is going on with 18 and play a little with the aggregation. And if you're not familiar with all these statistical numbers, we have here an AI-powered interpretation. Tells you if there is a correlation, if you can use this equation for further normalization, and gives you in the end here some recommendation what you can investigate more in detail. So let's go back to our source. And yeah, and from here you can go and run further regression analysis. You can normalize your data, or you can create a verified certificate where you have what you have here, an installation of some kind of energy saving measure, and you have a baseline before prior installation, and that you want to compare with the post installation period, and the certificate will give you an easy to read results certificate where you can see how much weather normalized energy savings in percentage and in kilowatt hours you have. I will go in detail in a new video, maybe tomorrow or next week. And yeah, DM me for a test account and happy energy saving.